In this video, we'll discuss static routing. Static routing is an approach that we can use as network administrators to manually configure routes on a router. This is a little bit different than using what we'll call dynamic routing. Dynamic routing is when routers share routing table information with one another, and they dynamically build up the knowledge of all the different routes that exist. Static routing is totally different in the sense that as an administrator, you would have to program the router for each of the different routes that you want the router to know about. One of the downfalls of static routing is, as an administrator, you're manually configuring the routers, which adds administrative burden to you as a network administrator. So that is something to consider when configuring static routing. The other thing that's important to consider is that these routes are fixed and they do not change if the network changes. So when you program the router and you tell the router there's a network out there called 192.168.3.0, and you can reach that by sending the data over to this IP address, if there's any changes to the infrastructure, the router doesn't know about that. With dynamic routing, it would learn of the changes as the changes occurred, and it would learn that from the other routers itself. So what kind of scenarios would we use static routing? First off, we use it when you want to program what we'll call a default route on the routers itself. So when a packet comes into the router and the router looks at the destination address and compares it against the routes that exist in the routing table, what happens if there is no route? Well, you can have a default route kick in. So as an administrator, you statically configure or manually configure that default route. Static routing is also very useful for smaller networks. So if we've got a small network environment with, maybe 2 or 3 routers, it's very easy for me to go and manually program the routing table on each of those routers because there's only a few routers. If there's a change to the network, maybe it's not a big deal because there's only 2 or 3 routers. So when I go to update those routers, it doesn't take a lot of time. When you start getting into larger environments, that's where you start seeing the problem with static routing and the administrative burden of you running around and updating all those routers. So typically we would use static routing as a complement to dynamic routing. So we usually load up a dynamic routing protocol so that the routers share knowledge with each other so that I don't have to program each router. And then maybe to tweak things a little bit, we'll add the odd static route. It can also be used to help transfer routing information for the routing protocols itself. So advantages of static routing: predictability. Because you're programming the routes and the routes don't change, everything is very predictable. You can actually visualize the flow of information because you've programmed the routers and where they need to route the data. Also, as far as network bandwidth goes, you've programmed the routers. The routers did not exchange data to learn of the routes with static routing. So one of the other benefits here is you're not utilizing network traffic or bandwidth to build up the routing tables. You're going to each individual router and you're programming the router itself. With dynamic routing protocols, or with dynamic routing, I should say, there's packets that are delivered back and forth on a regular basis to share the routing table between routers. So that's chewing up some of your bandwidth. So if bandwidth is an issue, then static routing is a good thing. Ease of administration, and that's kind of a questionable advantage. Ease of administration in smaller networks, absolutely. So if I have 2 or 3 routers, it doesn't take a lot of time to go in and program each router for the different static routes. But when you start getting into medium-sized networks and large enterprise networks, static routing is an administrative burden, so this definitely wouldn't be an advantage in those environments. Disadvantages to static routing: scalability. So you're programming each of these routes into the routing table. So you're building up those routing tables, potentially thousands of entries in the routing table, depending on the size of the network. Now, static routing should be used with small networks, so would we really have thousands of entries on a small network, right? But scalability is definitely a disadvantage. As your network grows, static routing becomes less and less desirable. Implementation Again, with large networks, static routing is just not something that we want to use, not only from a creation point of view, but also from an updating point of view. So as I need to make changes to the network, now I've got to go back to all the routers and reprogram them for the changes that I've made. So that becomes very labor intensive. And finally, redundancy. So there's no automatic failover of routes. Everything is based off what you've programmed. So that is another disadvantage to static routing. So in this video, we discuss characteristics of static routing.